Hi, we're going to talk about network security, and I'm going to show you how to attack a network and how to protect the network from these attacks as well. So essentially, I'm going to show you how to install a rogue DHCP server. So a DHCP server is used to assign IP address to end hosts on the network so that the hosts are able to receive information such as the IP address, the DNS server, the default router, and this will allow the end host to communicate on the network. Now, by installing a rogue DHCP server, the host, instead of receiving the information from the trusted DHCP server, they're going to receive from our rogue DHCP server. And this gives the opportunity to other type of attacks, such as ARP spoofing that we're going to see. And ARP spoofing, it will allow us to present ourselves as an end host or legitimate end host, or as we were the default router on the network. And by performing this type of attack, we are able to see the traffic from the hosts that are passing through the gateway. But before they will passing through the attacker machine, and we will be able to see the contents from that end user. So let's take a look at that. Okay, this is the lab topology we're going to use. So we're just going to focus on two sites, and that's going to be site 104, and we have this site here, site 105. So we have this R10, and it's going to act as a default router on this site. So we're going to use it to forward IP address requests from R35 to be sent over to R5, as it is going to act as the DHCP server. So the IPs will be sent using this network between R10 and the service provider, and then R5. So we're going to use also R34. We're going to configure statically the IP address, and then we're going to configure a rogue DHCP server so that then we can see how to prevent from installing a rogue DHCP server on the network. And here on the network, this cloud, this is where we have Kali Linux machine that we're going to use to perform the ARP spoofing attack. So first we're going to enable R35 and configure DHCP server just to see these working, what it would be a normal behavior when a host connects to the network. So I'm just going to bring R35 so that we can have a look. Okay, I probably already have this Windows 35, and if we look at 35, it has the MAC address statically configured. Just it makes easier to monitor, and is going to be assigned an IP address using DHCP. Okay, so if we look at R10, so R10 has a link to R26, that's the service provider network, and on the LAN side, that's the network or the IP 10.104.0.10. Okay, so first we want to make R10 as the DHCP relay agent so that it can forward the IP address requests from that LAN and forward them to R5. So we go to configuration mode, and on the LAN interface we're going to type IP helper address, and I'm going to forward the request to the loopback IP address on R5, and I know this IP is reachable from my LAN interface. That's awesome. Okay, now if we go to R5, okay, R5 also already has a JCC with service provider. We're going to configure the DHCP pool. So that's going to be DHCP pool, and we'll provide the name just to make it easy to identify. and you'll say the network is 00/24, and the default router is going to be R10, so 10.104.0.10. Okay, and now I'm going to exclude some addresses from being assigned to the end users. So it's going to be excluded address 10.104.0.1, 10.104.0, let's say until 99. Okay, so these addresses, they won't be assigned to end users. So when R35 requests an IP address, it's going to be assigned the address 100. So we're going to enable debugging just to monitor the logs, the debug IP, DHCP, server, packet detail. Okay, and I'm going to expand this a little more. Okay. Now if we bring 35, look, already assigned an IP address. Okay, and what's the IP? Okay, so it was too fast. It got assigned actually the first IP. So I'm going to release just to be assigned another IP address, and just going to clear IP DHCP bindings. Okay, if we look, do show IP DHCP bindings. Okay, so it's empty now, and we're going to request another IP address for 35. Okay, it was sent, so I should see now the IP 100, and yes, that's it, it's working. It was assigned the IP 100. So if we look the routing table, we can see that the default gateway is R10, so should be able to ping 10.104.0.10, and also the loopback IP of R5. And I also have telnet enabled on R5, so if we try to telnet 255, so it's working normally. So if this was a router or a PC that just connected to the network, that's the expected behavior. So now if we add R34 to the picture, and that's our rogue DHCP server. Okay, we assign statically the IP address 10.104.0.34. So let's see if we can reach R5. Yes, we should. 255.5. Okay, so R34 can reach R5 as well. So we're going to disable the interface on 35, and we're going to enable DHCP server on R34 as well, and we're going to see that 35 will choose the address pool from 34 instead the one from R5. So we're going to shut down the interface and just going to clear bindings again, and we're going to change the MAC address as well. I can just clear this on the switch actually. Okay, so let me bring the switch just to clear the MAC address. Okay, let me change the profile. Okay, so clear MAC address, dynamic, show MAC address. Okay, so 03 and 00. Okay, that's what we want. So now if we go to 35, the interface is down. Okay, that's what we want to see. And now if we go to 34, we're going to configure a DHCP service as well. So I'm going to say IP DHCP pool, and you're going to name it fake pool. So the network will be 10.104.0.0/24, and the default router we're going to set to ourselves. So it's going to be 10.104.0.34. Okay, and we want to exclude a couple of addresses. So we're going to say IP DHCP exclude address. So 10.104.1 until 10.104, let's say 199. So we want that our fake DHCP server to assign IP address starting on 200. Okay, so now if we bring 35, okay, and let's see who's going to get the IP address from. Okay, so instead of receiving the IP from R5, you can see it was assigned an IP address from our rogue DHCP server. But we can see that the request was sent to R5, but it wasn't fast enough, so it chose the rogue DHCP server. So you can see this is a problem, right? Because someone, either an attacker, or if you're running a virtual machine on your PC and you connect your PC on your corporate network, you can cause this kind of problem as well. So we want to prevent that from happening. Okay, so we're going to shut down again because we already saw that this can happen. So how can we prevent this? So the switches, they support a feature, and this is called as the IP DHCP snooping. So essentially, let me show you. When an end host connects on the network, so it's going to forward message asking for the DHCP server. So it's going to trying to discover whether there is a DHCP server on the network, and if there is a DHCP server, the DHCP server is going to reply with an offer saying, okay, I'm the DHCP server, do you want to use this IP address? And the end host then is going to send another reply message saying, yes, I want to use that IP address that you're offering. So that's going to be a request. And finally, the DHCP server is going to reply with an acknowledgement saying, okay, yes, you can use it. Okay, and the attacker is sitting there in between. So before the authorized DHCP server is able to exchange this message with the end host, so we have the attacker exchanging this message with the end host. And DHCP snooping will prevent those messages that are supposed to come from the DHCP server to come or to arrive on an interface that is not supposed to. So in this case, for this topology, we know that our DHCP server, the message, they should arrive on interface 00 instead of any other interface. So we're going to say all the other interfaces, we're not allowing them to send DHCP offer message, and only on G00. Okay, so let me bring the switch. This will make more sense. So first we're going to enable IP DHCP snooping, and then we're going to enable at VLAN because we just using VLAN 1. And so now it is enabled, and now we have to say, okay, which interfaces are allowed to send the offer message from the authorized DHCP server. So we can see that it's G00. So if we go to G00 and we're going to say IP DHCP snooping trust. Okay, now there is another fix that we have to add, because the message that's going to be sent from the switch, they will have a format that the DHCP server won't accept, so we have to remove that option from being sent to the DHCP server. So it's going to be no IP DHCP snooping. So we're going to enable debugging as well to monitor this message. So debug IP DHCP snooping. I believe that's events and packet. Yes. Okay, and let me see the console. Is it 7? Yes, it is. Okay, so okay, it's clear. So this is R5. Let me bring 35. Okay, now it's okay. And we have 34 still has the DHCP service running. Okay, So now if I clear MAC address dynamic, okay, and uh, let's try to enable the interface again on R35, okay, and R5 is replying, and we see a lot of message there, and we receive an IP address from R5, and we see that now the switch is blocking any offers coming from the port where R34 is connected from G01. And we can see here, let's see if we are able to read this. So we can see the DHCP offer coming from R5, offering the IP 10.104.0.102, and then we should see reply request. Yeah, we can see the request. This is coming from R35, and then we should see an acknowledge coming from R5 to use, so that 35 can use this IP. So we are able to successfully prevent DHCP rogue server on the network. So can we reach R5? So let's see. Okay, we still have access normal on the network. So now were able to prevent DHCP rogue servers on the network, but there's still one type of attack that can happen in this network, and that's ARP spoofing. And ARP spoofing essentially means that if there is an attacker, he's able to pretend to be R10, the gateway, from R35 perspective, and also he's able to pretend to be R35 from R10 perspective. And we're going to see this now. So if you go to my Kali machine, okay, so Kali has the IP 10.104.0.80, and we should be able to reach R5 as well. Okay, and we can. So we're going to use a tool to perform this attack, the ARP spoofing, and that's going to be ethercap. So I have to provide the root to open this machine, and as you can see, I'm using the interface E0, so that's the one I'm going to use to perform the attack. Okay, so I'm just going to enable this. Let me maximize this, and we are already sniffing on the interface. So if we look at the host, so first I want to see if from this PC I'm able to identify all the hosts on the network. So if we go to hosts, and we're going to select scan for hosts, okay, and it was able to detect 10, 34, and 102. We already know that 10 is the default gateway. We can see 34, and we have 102. So we're going to act as a man in the middle between R35 and the gateway. Okay, so we're going to select the 102 as the target 1 and the gateway as the target 2. Okay, and we're going to select here the ARP poisoning attack. Okay, so our attack is running, and another feature or another application we're going to use is Wireshark, so that we can see the packets that are passing from R35 to the destination. And let me bring Wireshark. So we want to sniff the packets on E0 interface. Okay, it's running. Okay, so if we go back, oh, we see a lot of message there. Okay, so can I telnet to 192.168.5.5? I can, and let me log in. Okay, so from R35 perspective, everything is normal, right? I have access to the network and things are normal. So if it's 104, can I ping my gateway? I can, obviously. Okay, everything looks normal. Now if we go back to our Kali machine, and let's filter just telnet, and look at this. This is the telnet session from 35 to R5, and we are able to see all the content. And we select one of these packets, and let's select follow TCP stream. We can see that we are able to grab the username, the credentials, and the password. As we can see, this is a very dangerous scenario because the attacker is able to sniff all the packets that we are sending on the network. Okay, and especially because we are providing credentials and we're using telnet, the traffic is sent in clear text, so we want to prevent this type of attack from happening. And the solution for that is dynamic ARP inspection. So dynamic ARP inspection is going to validate whether the IP and the MAC address that are supposed to be in a specific port, if a traffic comes from that IP and that MAC address on a different port, is going to be dropped. And dynamic ARP inspection is going to rely on a database created by DHCP Snooping, and that's called the DHCP Snooping database. So based on that information that is going to be created dynamically, so dynamic ARP inspection will take advantage of that database to validate the source and destination MAC address on the network. And we can also enable dynamic ARP inspection for static mappings, let's say for IP addresses that are not assigned using DHCP, but in this case we're just going to use it to rely on DHCP snooping database. So if we go back to the switch, okay, and let's enable IP ARP inspection, and we're going to enable on VLAN 1, and we want to allow we're only going to trust an interface where we can see different IPs of different MAC address, and it's the one connected to the default gateway. So that's going to be 00. So I'm going to say ARP inspection trust. Okay, and we see that it is already discarding the requests from our attacker machine. We can see it's trying to use different MAC address for others IP. Now let's see if we still have access. So 192.55, we still, okay, and 192.168.55. So my mistake. Okay, we're not able to telnet. Okay, let me do this. I'm going to just to close this, so probably now let me clear this, do you all, just to take a moment to clear MAC address dynamic, just to clear the cache. Okay, so in case the MAC address from 35 was detected on the port where the cloud machine is. Okay, now let's see if we can connect again. Okay, not yet. So probably it is being detected as being on port 3, so we're not able to have access yet. So let me see, do show MAC address. So we see 3035, it's on O2. Okay, so why it's not allowing? So you can see here, so the IP 102 still being assigned, is being detected as coming from G03. So I'm just going to request another IP address from DHCP server. So we're going to release this one. So I'm going to change to, let's say, 37. I'm going to request another IP address. So this is normally the situation where an end user complains about the network, and we just say, okay, just reboot the machine or plug and unplug your computer. And okay, now let's see if we still have access. Okay, and ping is working. What about telnet? Okay, telnet is working as well. Okay, and we are able to access R5. Okay, we got a new IP address, and let's see if anything changed from this side. If we clear this, okay, and you can see that now we're not able to capture anymore that IP address. And if you go back to our switch, okay, can I disable this? Do you all? Okay, so I'm just going to shut the interface because otherwise we won't be able to read. But you can see that it is being discarding all the attempts from the call machine to use the gateway with a different MAC address. So that's dynamic ARP inspection in place, and these are the two features that we can use to prevent DHCP rogue server from being installing on the network, and also ARP spoofing on the network. So I hope you guys enjoyed, and I'll see you in the next one.